You've probably heard that quantum physics is an impossibly complicated realm of science. You've probably heard that it has something to do with Einstein, time travel, E equals mc squared, and all that stuff. But what is quantum physics? Is it really as hard as it's made out to be? Quantum physics is simply the study of the very small, smaller than cells, molecules, and even atoms. At that scale, particles stop behaving like the things we're used to. Pictures like this one show electrons, protons, and neutrons as tiny circles, but these pictures are lies. Real atoms look a bit more like this, because subatomic particles can also act like waves. Imagine splashing in a pool, forming waves that spread out all around you, but instead of the waves hitting all the sides of the pool, the waves only hit at one point. Or imagine the sound from your voice only being heard by one person in a crowd. This is very similar to how electrons and other particles behave. Rather than act like tiny bouncy balls, they spread out like a wave, but still only interact at one point. This wave-particle duality causes many unusual behaviors. Particles can be in several places at once, teleport, and more. A bouncy ball is always in one spot at any time. But imagine one bouncy ball that is both on the floor and in the air at the same time. Electrons can do this because electrons are not bouncy balls. Electrons are waves. So just as this wave is in several places at once, an electron can be in several places at once. And just as this wave is stronger here than it is here, any electron is more likely to be found in certain places over others, but could possibly be found anywhere in the universe. Being in multiple states at once is called being in a superposition, and can affect not just positions, but other properties like momentum and spin. If you throw a bouncy ball at a wall, it will just bounce back. To throw the bouncy ball through the wall, you would need a lot of force. But imagine tossing the ball at the wall, only to have it come out the other side, without damaging the wall. Electrons do this kind of thing all the time, through a process called quantum tunneling. Because electrons act as waves and can sometimes be found in unlikely places, when an electron nears a barrier, it will sometimes pass right through it. Without quantum tunneling, the sun wouldn't even exist. All of the sun's energy comes from protons and neutrons quantum tunneling into each other to create fusion, as the sun isn't hot enough to create fusion on its own. So in quantum physics, particles act like waves, can be in several places at once, and can teleport through walls. But why does quantum physics matter? Our understanding of the quantum world has applications in everything from medical science to LEDs, and is the foundation of modern computing technology. And for the past 100 years, quantum physics has been the forefront of human knowledge about the world around us. Yet we're far from knowing everything. Many areas of quantum physics are still mysterious to us. But maybe you could be one of the many scientists that help unravel this impossibly complicated realm of science.